All right, so last class we learned a couple postulates for similar right triangles. And we talked about if you have an altitude and you know the length of the altitude, you can do side, angle, angle, side. And if you know the hypotenuse and a leg, then you can do hypotenuse, leg, leg, side. So let's use the information that we know to find the length of AC. So I see AC is over here. Well, one thing I could do to find the length of AC is if I see this is a right triangle and I come across from the right angle, I see that this is side C, or the hypotenuse of this smaller right triangle here. So I could just apply the Pythagorean theorem. 4 squared plus 3 squared equals C squared. And this is 16 plus 9, which equals 25. And then if I take the square root, I get 5. So now I can say that this side here is 5. Now if I want to find the length of DB, well, that's the side right here. And I know that I can apply SAS to find that. And so what I'm going to do is I'm going to set it up left side 3 over the altitude 4 equals 4 over x. And so what that gives me, if I cross multiply, is 3x equals 16. And then I just divide by 3. So x is going to be a decimal, which is okay. And I get the decimal of 5.333 repeating, which is 5.3 line over. So this side is 5.3 line over. Now I want to find AB, because that's the only side that I have left. So I could do one of two things. I could apply the Pythagorean theorem again, or I could do HLLS. So if I do HLLS, I have to know that the entire, this whole side is equal to the hypotenuse. So it would be, let's see, 5.3 plus 3.0, which is 8.3. So I could say 8.3 over x equals x over, so this is the side, and this is the side that attaches to it, so I have to put 5.3. And that gives me x squared equals 44.4 repeating. So then if I take the square root of 44.4 repeating, I get 6.666 repeating, right? So I can say that this is 6.6 repeating. And now if I wanted to find the perimeter of the shape, I'll just simply add it all up. So it'll be 6.6 repeating plus 5.3 repeating plus 3 plus 5. And so the perimeter equals 20. All right, so that's applying everything we learned last class. All right, let's learn something new. So now we're going to talk about some special right triangles. And one of them is a 45, 45, 90. So if you know that this side right here, this angle I should say, and this angle right here are both 45 degrees, there are some cool properties that you can see in your right triangle. And again, we're only talking about right triangles. And what you should notice is that the two legs, so we'll call this side A, this side B, and this side C, the two legs are equal to each other. And the hypotenuse increases by a square root of 2. So these are the rules. So if you wanted to find a leg, you could just take the hypotenuse and divide it by the square root of 2. And if you wanted to find the hypotenuse, you just take the leg and multiply it by the square root of 2. So these are the rules you have to remember so that you can apply them to find missing legs. So let's look. If we see here, we've got a 45, 45, and a 90. And so if I wanted to find A, this is a leg. This is technically C, the hypotenuse, because it's across from the right angle. I know that this leg is 7, so I know this side here is also going to be 7. And then I know that this side, the hypotenuse, is just going to be 7 times the square root of 2. And I can leave it like that because the square root of 2 is in simplest form. Okay, over here, I see that I have a 45, so I know this side's 45, which means it's an isosceles right triangle, so those two sides are going to be equal to each other. And so this is my hypotenuse, so I'm just going to divide by the square root of 2. Well, these cancel out, so I'm just left with 4. So both of my side lengths are 4. But you can see if you didn't know this rule, this would be a lot more complicated. But knowing the rule is a shortcut for us. And here we go. The hardest part is going to be identifying the hypotenuse. So if I know this side is 3 square root of 2 over 2, then I know that this side is 3 square root of 2 over 2. And then if I want to find my hypotenuse, I'm just going to multiply 3 square roots of 2 over 2 times the square root of 2. Well, I know that the square root of 2 times the square root of 2 just equals 2. So this whole thing is 3 times 2 over 2, which is 6 over 2, which is 3. So I know that this side over here is 3. All right, and then for number 4, I'm looking for my legs, but I have my hypotenuse. And I just draw this arrow to show me that it's across from the right angle. So I know C is going to be 16 divided by the square root of 2. And this side as well is going to be 16 divided by the square root of 2. But as you learned earlier, you can't have a square root in the denominator. So we have to rationalize it. So that means I have to take 16 times the square root of 2 over the square root of 2. Sorry. Let's do that again. I got to do 16 over the square root of 2 times the square root of 2 over the square root of 2. And so what I end up with is the square root of 2 over the square root of 2 is 2. So I get 16 square roots of 2 over 4. But then I see that 4 goes into 16 evenly. So my final answer is 4 square roots of 2. So both my legs would equal 4 times the square root of 2. So that's a special, that's when you have a 45, 45, 90. Well, there's another special right triangle, and that's a 30, 60, 90. So there are a couple more rules for a 30, 60, 90. So first of all, the smaller angle is always going to be 30, the larger 60. Okay, so the rules are the hypotenuse is equal to twice the short leg. So this is your short leg, this is your long leg, and this is your hypotenuse. So the hypotenuse is equal to 2 times the short leg, and the longer leg is equal to the short leg times the square root of 3. So these are the rules that you need to follow. And you can work forward and backward, so you're going to reference this page quite a bit. Notice that the short leg is always across from the 30-degree angle, and the long leg is always across from the 60-degree angle. And you can see that half of 60 is 30, so it makes sense. Let's look at some examples. So if I have this equilateral triangle, the first thing I can do is drop an altitude. And we know that since all the angle measures are 60 in an equilateral, this one is going to drop it, cut it in half. So both of them are going to be 30. So now you can see our 30, 60, 90 triangle. And if we know that the hypotenuse is 8, we know this entire leg is 8, but our altitude cut it into 2 pieces. So I know this side is 4, and this side is X. So we want to know what the altitude is. Well, the altitude is also going to be the long leg, because it's across from the 60. So if I take the short leg, which is 4, and multiply it by the square root of 3, then I'm golden, and And that is my answer for what x is. So we can do the same thing over here. And again, we're going to drop a altitude. And I know that all the angles in an equilateral triangle are 60 degrees. And I know that this side is going to be 10 because all the side lengths are also congruent. And if this side is 10, then I know this side is going to be 5. So once again, I want to know what the altitude is. It is the long leg, right? So I just multiply it by the short side by the square root of 3. So my final answer is 5 square roots of 3. And again, the hard part about this is going to be memorizing the rules. That's going to be what you need to know how to do. So let's try a couple more. These are a little bit more complicated. These are not equilateral triangles, but they are 30, 60. So this is my 30, this is my 60. Now I know the long side. So to get the short side, I just take 10 square root of 3 and divide it by the square root of 3. These cancel out, and I'm left with 10. To get the hypotenuse, I just multiply the short side. So 10 is my short side, and I just double it. So it equals 2 times 10, which equals 20. Another example, if this is a 60, I know this is going to be a 30. Okay, so I know this is my short side, right? So if I want to find, let's say I want to find my hypotenuse first. So x is my hypotenuse. I'm just going to take my short side, 3 square roots of 2, and multiply it by 2. So you just multiply your whole number, so I get 6 square root of 2. So that's my hypotenuse. And then if I want the long side, so this is the long leg, this is the short leg, this is the hypotenuse. If I want my long leg, which is y, I just have to multiply it by the square root of 3. So this would be 3 times the square root of 2 times the square root of 3. And you end up with, multiply your radicals together, because they're like terms, 3 times the square root of 6. And I know 6 can't be simplified, so you just leave it like that. All right, the last example we're going to do together is this one here. And again, I know my long side, my long leg. This is my short leg, and this is my hypotenuse. So if I take my long leg and divide it by the square root of 3, I end up with my short leg. So this is 2 times the square root of 15. I'm going to divide it by the square root of 3. Now, I could rationalize my denominator, or I could just simplify my radicals. And I know that 3 goes into 15 evenly, right? So I can just simply say, just like you can multiply radicals, you can simplify them as well. But they have to be under the radical symbol. So 3 goes into 15 5 times. So it's just the 2 square root of 5. Well, now I can take that and multiply it by 2 to get my hypotenuse. So my hypotenuse, m, is equal to the short side, which is 2 square root of 5 times 2. So that gives me 4 square root of 5. So that's my final solution for this one. All right, well, thank you for watching, and I hope this helps you to do your practice problems. Please remember, you can watch this video as many times as you want. The key is to know the properties, like what you're looking for when you're solving this. All right, good luck.